ArrayList. So here's my ArrayList class. So it's a private class. I don't remember what I called it. My ArrayList iterator. Iterator implements iterator E. I need an E here. Squiggly, fix it by importing the Java util. Squiggly because I don't have any of the methods. I add the unimplemented methods. The has next, next. And this remove is optional, so we can do something like throw new unsupported. What? What did you do that for? Unsupported operation exception. Oh! I love it. Guessed right. Okay, so what this means is that whenever someone calls remove on my iterator, it's going to throw an exception because I didn't implement that method. I have to implement the method because the interface says I have the method. So I want to indicate that I didn't, you're not supposed to do this, so I'm going to throw an exception. You could do absolutely nothing. But that's sort of mean to the user because the user thinks that you actually removed something because the method says you removed something, but you didn't. That's a little not nice to the user of your class. So back to his. So how do we know that we're done with our iteration? We've gotten to the end. We've iterated over everything. Well, one easy way is to say if not has next. Right? So if we've gotten to the end and there's no next element, then we can throw our exception. No. Okay, oops. So I have to import it. Okay, so if we get past here, then we know there is something next. There is a next item. So we could do it the safe way. So how do we get that item? Well, we could use, oh, I forgot here. We have a private. So this index keeps track of where we are in our iteration. So we can say data sub next index. So that's going to be, what's wrong with that? Cannot convert from an E to an E. Weird. So that's the item at the next index. Then we say next index plus plus, and then we return. We could all do that on one line. We could just say return data.next index plus plus. And we may have to cast it to an E. Yes?
You do next index plus plus before you set the return value.
You end up pointing at the wrong place. Because let's pretend that this is my array. Ignore the arrows. This is my array. So this is 0, 1, 2, 3. And so what I do is I start this by so I say, to initialize my thing, I say next index equals 0, right? So that will point to the next item I need to return, right? So I want to return the 0th item. If I do plus plus first, I'll return the first, this item at 1. So I'll miss 1. So you want to do the increment after you've gotten the value out of the array. And again, we're just copying the, we don't remove it. We don't have, the iterator does nothing to the array. It just goes through the, we don't muck with the data. We're just returning the data. Yes?
What if you put data next index plus plus?
In the return value?
Yes.
Yeah, you can remove that line. You only want to increment it once, right? We don't want to increment twice. Okay. And you can actually just say return data sub next index plus plus. So it's only one line of code. Okay. Any questions on this? Yes?
What if you hadn't done it as a nested class? You wouldn't have access.
You don't have access to the things.
So you pretty much have to do it as a nested class.
Right. Yes. We'll talk about that very shortly, actually. So the last thing that I want to do today is talk about this. Give you a sense of what you need to know for the exam. And since we started off with Java, review of Java basics, you should understand what the access levels mean. And that goes to this. Our member variables are generally private because we only want our class to access them, no one else. Right? If they don't have, or if they're protected, let's start off. Public. Public means everybody can see them, everybody can muck with them, everybody can touch them. Our public member variables are very dangerous because someone else is going to muck with them. You don't want someone else mucking with your stuff. Protected. Protected means that your member variables are accessible to classes in the same package. What's that? And subclasses. So if you want to subclass something and have the child class access it, change it from private to protected. If there is no access level label, it's available to the class and the same package, but not subclasses.
Is there an access level for when you want the member variable to be accessible by the class and subclasses, but not by the classes in the package?
No. Protected is the only way to go. The default is none, right? And that's accessible by the same package, but not subclasses, unfortunately. And then private is only accessible by that class and any classes declared inside that class. That's why our list iterator, which is a private class inside the class, can access the data array. Data types. You should know the difference between primitives. Primitives have no methods. You can't call a method on a primitive. Everything else in Java is an object. Every class in Java is a subclass of object. Everyone. So object is the superclass of all Java classes. The classes tend to be, the idea is, you know, in the book they have the picture of the little fortress with the gate. The methods allow you access into the center of the gate, and the member variables, the state, are inside there, and they're generally private. We don't want the people to know exactly how we implement it because they don't need to know. You could do an array list, you could do a linked list. They don't need to know how you do it. It's up to you. We have arrays. You have to initialize the array. And that creates an array of references. Does it initialize any of the references? No, they're all null. If you want to actually set the value in an array, you have to actually set the value in an array. And again, an array does not have any methods. You don't call the length method on an array. You don't call the size method. You call the property length. And a very valuable method, system array copy, right? Allows you to copy from one array to another array, determine where you start, how many you copy, where you go. Very valuable method to know. Abstract data types, that's what we're basically talking about. We make the variables private, and we have accessors, behavior. You know, what is the list size method? Sort of an accessory saying how big is it. What does the add method do? It changes the behavior of the list. It allows you to add something to the list, which changes the system. Question, what is the difference between an abstract data type and an abstract class? Yes, an abstract abstract class has methods that are declared abstract. You cannot instantiate an abstract class. Abstract data types, like the list, or the array list, or the linked list, can be constructed. You can actually create an instance of it. But the abstract data type is the concept of a list, or we'll get to stacks shortly, and queues and stuff. So it's a way of storing or holding or manipulating data. They both have the same word abstract, but they're not the same thing. No interfaces versus inheritance. So which is it? Which is the interface? List E, because it implements the interface and extends the superclass. Yes. So extends means that ArrayList extends abstract list. It inherits all the non-private methods and non-private member variables. There could be, if you want to get philosophical, it could inherit the private methods, it just can't call them. It could inherit the private member variables, it just can't use them. Don't worry. But do know what inheritance versus implementation means, or extends versus implements. Implements means this class will implement every method in the interface or be abstract. So if you say you implement list, you must implement all the methods in list. Here's an example of an abstract class. Vehicle. You can't instantiate a vehicle. you have to instantiate a concrete subclass of vehicle. And the idea here, or in this example, is if I have a vehicle and I have a method called move, I don't know how to move the abstract vehicle because what if it's a submarine? Moving a submarine is very much different than moving a truck or an airplane. They all could be vehicles. They could all have the method move, but the vehicle class doesn't know how to implement or have a move method for each possible subclass. So it's, the designer decided to make it abstract. We talked about sort. I gave you a hint at the beginning of class. Know how to implement all three sorting algorithms on an array. You may want to focus slightly on bubble sort. Unless I'm mistaken and misremember, which my memory's shot. So, but I believe you should know all three. And also know the big O for all three. Why is bubble sort and insertion sort big O of n in the base case? If you're sorting the sorted array, both those sorts will detect that they didn't do anything after they did that first loop, and they stop. So they passed through the array the first time, they did nothing, they stopped. The selection sort, however, can't, because it's going to say, find me the smallest one, and find me the next smallest one. And oh, by the way, it's always going to find that one, but it's got to search the entire array each time. So it's going to be n squared best case. List interface. Is that right? Get that index added. Oh.
Yeah, is there another add specific?
That is? No. Add index. The one that's on here, item that contains, you put it down. If you don't put it down, I won't be upset with you, because that actually comes from the collection interface. That's where it's defined, because you should be able to search a collection to say, does this collection have this state? In the homeworks, I didn't have index of the object. That's in here because what is one of the fundamental things about a list? Each item in the list has a position in it. They are positioned in the list. Are there any gaps in a list? No. If you add something in the middle, the index of the ones that were greater get incremented and are larger. If you remove something, they shift. So know the list interface. Be able to write it down on a piece of paper in about 4 or 5 minutes. An array list. We use an array to store the items in the list. One of the benefits of an array list is it's quick to get and set items. Why is that? Yeah, you're trying to say, what's the item at index 3? What do I need to do? Return the item at index 3 in the array, right? So that's very quick. One of the other, is it positives? One of the negatives is, if you add to the end, you may need to resize the array and copy all the stuff into the new array, right? You got to have space to store it. So that add can cause that one add is going to be expensive, but it only happens once every n times, so we still say that add is still a big O for it. One of the bigger issues with the array list is you got all this empty space at the end. You're wasting space. You're wasting storage. Now, is that a problem? Depends on the problem and the system you're working on. If you have a very limited amount of memory, this is an issue. If you have very large arrays, or excuse me, very large lists, that can be an issue because often the amount of wasted space is like almost up to 2 times the amount of space you have in your, how many items in your list, depending on how you do that resize. So that is something to think about. The access is very quick. Every once in a while, you got to copy all the data, but you are wasting space. And when you do an insert in the middle and a remove, you got to shift. So those are expensive operations. Linked lists, we store the data in a linked node. You should know in your sleep what a linked node looks like. You should be able to write it. You should be able to write a doubly linked node. You should be able to understand how we do the traversal. What do we keep track of in the list, in the linked list? The head, the size, we have to keep track of the size for both of them, and the tail for efficiency's sake. Okay, so there's no wasted space. There's no extra nodes floating around waiting to be storing stuff. We only create as many nodes as we have items. We don't have to copy the items to shift them around. Because they're nodes, we can just insert in the middle and redo the links, and then there's no shifting. It's very good. The problem is that in order to get to any item in the thing, we got to start at the head and move forward. That's expensive. And, oh, by the way, as you guys learned, it's more complicated. You got to keep track of these links. You got to make sure that they're correct when you do the setup. And you know, it's like if I add one here, I got to maybe add before, add after. The class itself is much more complicated because you got to manage all these links. So, what is this? It's a singularly linked list, right? We have a head, we got some nodes, we have a tail. Now, if I'm at tail, where can I go? I can't go anywhere. I have no way of getting to head without just saying, well, make temp equal head. I have no way to traverse to head. I can't even go backwards one, right? I have a pointer to null that's next, and I fall off the thing. So one of the things is by adding the tail next equals head, we now have a way of continuously traversing the singularly linked list. Right? If I'm at tail, I can get to the head, I can go on, I can keep going around in circles. That is convenient. Because now I don't really need a head anymore. Tail next is the beginning of the list. So I could throw away the head pointer and just keep track of tail. So now we could go from the tail to the head in a circular doubly linked list. Now, if I want to go from the tail to the head right now, what do I have to do? Go previous so many times until I'm pointing at head. Well, that's big O of n, right? I have to go all the way through the list. So if I make tail dot next equal head, is that what? Or head dot previous equals tail, right? So now I've linked the head to the back, and then I make the tail next head. So now I can just go in a big circle. What's one of the issues with this particular structure? You don't know, you have to do a different kind of check to know when you're at each end. You're not checking to see if previous is null or next is null. you're saying, am I pointing at the head or the tail?
Also confusing with all the references.
Yes, there's, each node only has one extra reference, but now it's sort of like, where am I? How do I, and then in this case, it gets confusing with the temp.next.previous, right? So I told some people, I draw this stuff out on the board or on a piece of paper to go, temp.next is this thing, now I can change its previous to point to something else. Because I think visually, I don't know if you guys all do, but many computer science types do. So now you can traverse in either direction. Be very happy I didn't give you the Josephus problem, which is a doubly linked list with an iterator that calls remove. That was a really fun, hard one. But I didn't give it to you guys this year. Okay, so what's the idea behind the iterator? It's a way of getting access to each item in the collection. It's in collections. It's actually in the collection. So we're just doing it for the list, but when we get to queues, they have an iterator. If you have a set, they have iterators. So if you have a tree, you can even have an iterator. So it's just a way of making sure that you can visit every item in the collection. Yes, because it remembers where it is, right? So there's no, but there's also, but if you want to say, I get to the third one, it's still big O of N to get to the third one. You have to call next 3 times. But it is more efficient if you're going to loop through the list or the set or the whatever. It's much more efficient to use the iterator because each time you call next, that's a big O of 1 operation. And so the concept here is that you actually are sort of between the items, right? So I can say this is the previous item if I'm using a list iterator, or the next item. So it's sort of hard to think of that I'm between them, but certainly with the ArrayList iterator because you keep track of the next item, the index of the next item. But you get the concept that you're sort of between them, and you can go left or right. And the enhanced for loop, this will be on the exam. You can do a for loop on something that is iterable. Right? That just means that we're going to use the iterate method on that object to get each of these parameters. Because the iterable interface has one method called iterator, which returns an iterator on that collection or on that thing. So this is a very nice for loop to say, if you want to loop over all the things in the list, just say for E whatever colon list, in the variable that is the list, and you will then loop over each item in the list. Well, the iterator, right, the iterator basically has a has next Boolean and a next operation that returns the next item. So this for loop is going to run until has next is false.
Okay, so it's like a normal for, but it just already has all of the conditions.
Yeah, it's basically, because there is no, because we don't have the, an iterator just says I'm going to go through each item in the thing. So I don't know if they're ordered or not, but it's supposed to return each item in the thing. So this for loop is going to loop over each item in that thing. And we do it because we know that when we call iterator internally, the for loop is going to call get the iterator and then say while iterator has next. This is a very, very nice for loop. And it's a very nice way. It's basically a shortcut of writing a lot of, while iterator has next, E item equals iterator dot next, and then you go and do stuff. That's all in that one for loop. else do I have? Big O. What's the big O of this code? N, right? How do we know? We have, how many times do we do the while statement? How many times, right? We're going to do it n times. And yes, they all have their own amount of time they take up, but the equation, if you do it, you then end up with, right? We do C1 once, we do C2 twice, and then we do N, C, whatever, and then that's big O then. Because we don't care about the coefficients, we don't care about the other pluses. Now that's true when we talk big O. It's very true that this is a big O of N algorithm. But the coefficients might be important. Because if N isn't big, all of a sudden the coefficients are important. And that's why they say, you know, the three sorts that we learned, they're all big O of N squared. They're more efficient than some of the faster sorts we're going to learn later on in the class for small sizes. Because the other ones, even though their big O is smaller, they have a big coefficient in the front. So, just because you say, I'm always going to choose the smallest big O, that's not always the best choice. You do have to worry about the coefficient for small values of N. Questions? Is there anything else we learned so far? Yes?
I guess this is not something that would be on midterm, but if you wanted to fully implement this interface, like not just what we did in the assignment 3, but if you wanted to implement the iterator method, how would you return? Would you have to return a nested class?
Well, because see, my ArrayList iterator implements iterator, so I can return a new myList iterator as an iterator. It is an iterator. So I would return a new one of that. I would return a new instance of this class. So I'll even do that. Where is it? Implements table. Is that right? So that's down here.